Hey folks, today we're going to be going through something a little bit more complex. We're going to be dealing with AI. You can see that these AI are following me around the space, and when I get out of the picture, they'll just kind of mill around and do their thing. And if I click, that triggers an audio response, and they respond to that by saying that they can hear me. When I'm actually in said space, they will rush over to me when I kind of trigger the audio simulation, and also they if they see me, they'll come and follow me. We're going to reconstruct that. I'm just going to kind of delete these elements for now. There's the third. Kind of get away from me, and I'm going to move this camera into our main space. Now you'll see here I've created a little bit of a, not a salt course necessarily, but space for the AI to kind of navigate around, something a little bit more interesting than just a flat area. So the first thing that I'm going to do is I'm going to navigate to this folder here. So the way to do that is content, default content, packages, third person blueprints, and then this. It's not optimal, but it is what it is. So so let's you're going to have just this third person character blueprint in here. If you right click on that and click duplicate, I'm going to create a character called AI pawn. So that now can go in the space, and you can see from the offset it's not actually very useful to us, because it's still inheriting a lot of the functions of the third person character. What we want is a third person AI, not a third person character. So I'm just checking the audio is still working. So the things that we need to do is, firstly, we want to open it up. We want to purge all this code from in here, so getting rid of all of that. And then we're going to get rid of the camera boom and the follow camera block. So both of those have got to go. Compile that. And what you'll find now is that this is now kind of prepped for what we need to do. I'm just going to do one more thing real quick. Just disconnect this here. So what we're going to do now is we're going to create a emitter for this character. So we're going to add some components back. So inside of our AI pawn, we're going to create a noise emitter. Sorry, no, we're going to create a sensor, not an emitter. Pawn sensing. So that's basically going to detect when stuff is in range visually, or whether it's kind of in range audio wise. Now, if we go to the viewport, you'll see that nothing appears to have changed. That's because we need to compile. Once we compile, it shows the sensor. Now, this thing is kind of a bit of a bizarre thing to initially look at. If we zoom back, you can see that there's a series of different kind of radiuses, or radii, I don't know what the term is. The main one that we need to worry about just for now is the peripheral vision. So this is kind of in a bit of a janky way right now, because it's set to 90 degrees. I don't know why they do it, because it basically breaks the vision of the character. But if we set it to like 45, that kind of gives you a reasonable vision cone to work with. Unlike the fringe cases of like running, what's the word, like 90 degrees to it, it'll if you literally like strafe around it, it won't be able to keep up. But for most cases, it will still pursue you. So if I click on event graph, as you can see that navigation cone will actually encompass the player to begin with. So we're going to create one piece of logic in here. So with that sensor selected, one more thing as well. Oh no, that's it. We're fine in here now. The only other thing I'd mention is we've got the sensing interval. You'll see that when the player is being detected, you'll see it kind of tick over that message roughly around half a second, per update. So we're going to select this here, this pawn sensor. we're gonna whoops, without changing its name. Okay, we're gonna right click in the main space. We're gonna add an event, and this event is going to be checking to see if we can see a pawn. So in this case, it's going to be our player pawn, because remember, you've got standard actors and then you've got pawns. So pawns are basically like blueprints that have a little bit more complexity to them. Usually it's like more advanced elements such as characters or AI and enemies, stuff like that. So just compile that. We're going to do a real simple script. So just print string, and we're going to do I can see you. Compile that. And we can just give this a quick test now. So you can see immediately from the offset it can see us. If I hop out of view, knock knock's just coming from the door behind me. Doesn't show up. If I pop out, it's got kind of like a raycast where it knows if you're visible or not, which is quite useful. Good for stealth games. So now what I'm going to do is not look at that. I'm just going to add one really simple script to this that should give us some functionality. So AI move to. It's a little bit different in terms of the icon to stuff that we've dealt with before, but it functions basically the same as what we would otherwise. So the only thing we need to do as part of this is we need to set, like, this is confusing because this looks like this should automatically connect to here. That's not the case. This should be connecting to here. So as with other actors, the pawn here is the other actor, not the AI. So this is the player. So the player is the target, not the actual thing that we're trying to motivate to move or kind of signal to move. So this is just going to be a reference to self. And what we should find now, if we compile that, is that our character... Oh, did I not connect up the execution pin? What did I miss there? Bear with me a sec. Oh, yeah, sorry, I missed something really fundamental. So you might be wondering why this character isn't moving right now. It's a pretty obvious reason. We don't have any means of, it doesn't have any means of understanding how to navigate the environment. So for that we need a volume, and that volume is going to be a nav mesh bounds volume. And that is essentially an area that your AI can kind of move around in, and it'll kind of calculate what can be traversed and what is inaccessible. So I'm going to scale this up to match the space. And if it's not very clear what is included in that space, if you push P, it'll kind of paint everything that is coloured with it. If you're wondering what's going on over here, I've got another nav mesh here for this space. And yeah, you can see that it quite elegantly decorates the space. I'm just going to bring mine in just a little bit, just to not include the entrances because it gets stuck on those because of the doors. You can kind of tag the doors as it not colliding with or not having it disrupt the nav mesh, but there's plenty for us to go on to in the tutorials. You can kind of explore that in your own time if you wish. So if I now test this, the AI comes straight after me, which is great. And you can see it does a little bit more advanced stuff as well. So if I'm jumping off of platforms, it'll chase me off of those. It's not always as kind of reliable. You can use things like navlink proxies to make sure that happens. Again, you can go into those in your own time. But yeah, it's pretty advanced in terms of how it can kind of follow you around the space. So I'm pretty happy with that now. So what we're going to do next is we are going to get our player sensing whether there's indicating whether there's noise emitting from them, and the AI responding to that. So this piece of code here, we're going to end up reusing a bunch, which is pretty handy. So what we're going to do is we're going to select this again. We're going to right click. We're going to search for noise. And you'll need to scroll to the top. Remember, don't pick the first option it gives you. Add on here noise. This block here. So what that's going to do is on a sound being initiated, it's gonna trigger this event. So if I search for print, I'm gonna do I can hear you. Kind of very ominous messages. So that's good. That'll just do its thing now, which is great. So the thing that we need to do now is inside our player. We need to create our logic for that. So I've already created this pawn noise emitter. You can do that from in here. You can do pawn noise emitter. I'm just going to use this version of it that's already created because I've already done like a 40-minute recording of this tutorial before, and I had all sorts of problems with having multiple emitters kind of signaling to the wrong actors. Because again, as part of this tutorial series, I've got like 4 different versions of the same entity, and it caused me a bunch of problems. So I'm just going to keep things nice and simple and just keep it to one emitter. So yeah, to be blunt, I can't be bothered splitting those up. I've already wasted enough time on that front. Okay, so what I'm going to do is I'm going to grab this piece of code here. So make noise. So make noise, and it gets the reference from here. We need another piece of code as part of this. So this won't trigger in itself. We need something that initiates the event. So we're going to do mouse button, left mouse button. So for your own projects, you may want to choose something a little more elegant. So if you, let's say, do something like the player moving at high speed, or not crouching whilst moving near an enemy, you might want to make that generate loudness. And you could tie that. You could tie that. The control key being held down to making noise. Yeah, that could work quite nicely. So yeah, that would be relatively straightforward to do. But for the purpose of this, I'm just going to keep things simple. So the things that we need to do as part of this, we need a reference to the player, because you can see it's throwing an error. So we need to indicate that's the noisemaker, and then we also need to do actor location. So that actor location we've got there will indicate where the noise is emitting from. So, and we are going to do print string. I'm going to lean into that horror vibe again. It was there. So now, if I say, who is, oh wait, I need to get out of range. Run away, run away, run away. Oh god, I'm not going to be able to escape him. Ooh. Oh god. Yeah, I can be very, very persistent. Okay, I'll run out of the space, hopefully. Oh god, he can still see me. I'm just going to run around the outside. Oh. Okay. Oh, sorry, this is a different door mechanism. Bit fiddly. So now it can hear me, but it's not reacting, so I can get right up close and it'll react even though it can't respond yet. So we need to fix that. So what we're going to do is we're going to just chuck in this piece of code, so we can reuse the code that we had before, but we are going to make a slight modification to it. So unlike the logic inside of here, where it needs both references, otherwise it throws an error, inside of here we can use either or. So we can either use the destination of the player, so we can use destination or target. It accepts both. So I can't remember if it accepts location. I'll quickly test that to see if it does, because I would be curious to see if that. Oh god, I'm going to have to outrun it again. Okay, I'm just gonna move my. I'll tell you what. Easiest thing I can do is just give that character 180. There we go. Cool. So yeah, that doesn't work. I thought it wouldn't. Okay. Cool. So what you need to do is instigator, actor location. I'm not sure what the kind of differentiation between those two is. Yeah, but with this one, it accepts the reference, and the reason we want to do destination rather than target actor is if we wanted to do like a stealth game or a horror game. Sound is like a really powerful tool for like interaction with AI. So, for example, if you had like, let me think. There was a Splinter Cell game. I can't remember which one it is. I think it's Conviction. I can't remember. But basically, in that game, you can choose to make noise as a tactical decision to lure enemies to specific locations. So you could, for example, fire off an unsilenced gun in a space, draw all the enemies within like a 20-meter radius or more to that location to get past them without having to kill anyone. Yeah, it kind of leaves a little kind of residual ghost of you behind in that location, having done that act. So you could imitate something like that pretty easily, where instead of having it target the actor, by having it target the destination, it won't actively follow the player with knowledge that it doesn't have, if that makes sense. So it's not going to immediately know where the player is. It's going to investigate the location that noise was emitted. So yeah, all you need to do now is connect that across. And yeah, that should now, if I can sneak up behind this character and try the same trick, comes after me. And then at that point the sight takes over and will kind of persistently follow me. Gets a little bit confused on corners. As I said, like with 90-degree turns, it kind of struggles quite badly. But you can adjust the radius of the what's it called, the radius of the sight line to make it react differently. So yeah, so we've done that element now, which is great. As I said, it can get a little bit confused with multiple emitters, so just watch out for that. So what we're going to do now, just real quick, is we're going to do some code for some comments for this section. So if you want to do comments, you can do select your objects and press C. So we're going to do so sensing check if player is seen, move AI to target actor. And we're going to do the same here. Player is heard, move AI to location of last noise. Okay, so yeah, so that's great. One thing you might also want to do is if you just disable those, the bubble effect, it just means that you're not going to have your scene when you zoom out filled with those ridiculous speech bubbles. So yeah, that's all good now. So there's one more piece of code that we need to create as part of this that should be relatively straightforward. It's a bit more complex than what we had before, but should still be manageable for most of you. It might take a couple of run-throughs for those of you that find it a little bit more confusing, but that's what these videos are for. So we're going to create a blueprint class, and we're going to create a thing called, I've got lots of different names for these, so it might cause a problem, so marker nav. So this is basically going to be like a nav marker that's going to create different waypoints for the player in the level. So, yeah, I'm going to just pop this open, and I'm going to create a sphere as a visual indicator in the level whilst I'm just kind of placing these in the space. If I just compile that, and one more thing I just want to do is have it hidden in game because I don't want those to show up. So this is like if you had like an AI, again, if we use something like a spy game, for example, we had like an AI just kind of like navigating around a space, just patrolling. You could use this to, to give the player a predictable path that the AI is going to take. So you can see as I'm placing these that the nav mesh is having a little bit of an issue with the placement of these. And the reason for that is that these still have collision. And because of that, it is knowing to kind of navigate, as with the doors, as with the walls, and as with these stairs in the middle, that if there's like a obstacle, it should probably not try to go near it. This is going to be a massive problem with our markers because these are the things it's meant to be targeting. So we need to change the properties of these. So if I come into here, I can set this to have no collision because it doesn't need collision to be blunt. Now, if you, as I said, if you want to kind of explore further into how you would get the doors to, for example, not intersect with the nav mesh, I'll leave that for you to discover in your own time. But yeah, for the purposes of this now, that's solved that problem. So what we're going to do now is, don't forget to save, so Control, Shift and S to save everything, not just specific objects. We don't need to do any more code in this, so that is now can be closed. We are now going to come back into our AI and we're going to create two pieces of code just to begin with. So the first one is we're going to do a begin event. So event begin play. And then we're going to do a for all actors. Sorry, no, it's all actors of class. So you need to watch out on this one. In the last recording I did of this, I searched for actor of class instead of all actors. So that will give you an output of an array. Just to show you the difference, you can see that this outputs a single variable or single entity, whilst this outputs an array. We want this version, not the other one. So if I enter what class I'm wanting to search for in there, so that's the marker nav. This is now outputting an array, so what we can do is search for a for loop. So for each loop of the number of items in the list. Let me just quickly check something. Yeah, cool. So what we're going to do now is with the loop, what you'll have is like a repeating process that for each item in that list, it's gonna run a sequence. You've got two execution pins here. This one's going to trigger at the end once it's kind of processed all of those different items. This one's going to run throughout it with each iteration. So we're going to drag off from this one, and we are going to get a reference to. So we're going to. Oh, sorry, no, not from there. So from here, we're going to get the actor location. So what this is going to do is we're going to be able to assemble a list of all the navigation points into a list. So at the moment, this isn't very useful because we need a place to store this. So we need to create a variable to occupy that. So we're going to call this locations. And this isn't in the right format. We need to change this from a Boolean to a vector. But even that just in itself isn't enough. We also need to change it into a different container type. So we need to change it from a single variable to an array. So now if we compile it again, what that's going to do is it means that for each of these loops that occurs, we can now add, if I just drag this in here as a reference, we can now add each one of these outputs from here into our list. So each time that this loop runs through, it'll add an item to the list. And what we can do from that is, just real quick, drag a little bit of a gap, test that, and it'll show us each of the items in the list. So you can see that it added 5 items to that, which is pretty handy. Obviously, it doesn't tell us what those items were, but we know that there's 5 items in there. And one thing you'll notice with that is that it went 0, 1, 2, 3, 4. So remember that with arrays and lists, it counts from 0. It starts the count at 0 instead of at 1. So you need to factor that in when you're kind of referencing your list. Otherwise, you'll get like list null reference errors and all sorts of horrible stuff. So I can technically delete those now. And I'm going to just do, again, this piece of code that we had before. So grab those, drag them into the space, and that just needs one more piece of code here. So get reference, whoops. We need to link this to here. So you could have just done it from there, or you could have dragged off from here, get ref. And what that's going to do is that's going to get the first item in that list. So if I connect that to there. Now, this isn't actually going to work. This is going to cause like some weird glitching with our character. So if I just kind of simulate, it's going to run to the first location and then do nothing, which isn't what we want. So the way that we can fix that, to be fair, I think that might be the 5th placement, but I'm not 100% sure because I think it's the last item in that list. So what we need to do instead is, rather than connecting that to there and connecting this here, we want to create a custom event. So I'm just going to drag this down just a little bit. So we're going to create a custom event. Now, again, just in case you're kind of searching for this piece of code, this patrol code is a custom event. And I could call it whatever I want. I could call it like, I don't know. I could create a custom event called like shark food. And now I can search for, it's like a variable, it's custom information that is kind of bespoke to your project rather than something standard in Unreal. So don't go trying to search for this without creating it first in your own projects. So that connects across to there. And this will actually, even this is still not going to be enough to kind of trigger the event of them kind of going to a specific location. We need to actually initiate it. So that's going to be from here. So once that loop's completed, we are going to trigger patrol. Compile that. And now, if I do a simulation of that, the AI runs to where it should have been running, which is that first location. And what's nice with that is I can just nip into here. I can change which number I want it to, whoops. Yep, so I've changed it to 1 now. So you'll see when I simulate it, it'll run to that node instead. So the obvious question next is, how do we get it to randomly choose locations instead of picking a specific one? That's relatively straightforward to fix, although we will need to add some extra stuff on top of this. So random integer in range. Remember what I said before, it's not 0 to 5 or 1 to 5, it's 0 to 4, not 0 to 44. That will now choose a random one of these locations to start with each time. So you can see it chooses a random placement. And notice I'm doing this in simulation mode, which you can access from the drop down. So it chooses a random one to start with from each time. Apparently it really likes this corner. Let's try it one more time. Okay. Yeah, so it's, yeah, there you go. That's enough of a variety for me. So, so now what we're going to do is, obviously we need that to continue as a thing. We don't want it to just stop. So we need to add some more code to the end of here. So we're going to have, with the patrol code added to the end of this. So when it's successfully reached the location, it's going to run that sequence again. So if we try that now, it should continue forever. So, yep, that'll just keep navigating around the space. It really doesn't want to go on that top navigation point. I wonder when it's going to do that. Here we go. Nice. So that's great. Oh yeah, now it's going for it all the time now. Okay, so yeah, it really likes it now. Okay, so what we're going to do is there's one more thing that we just need to change to this to make this a little bit more effective. That is basically if you add more nodes to this, it's not going to respond. It's going to only have those first 4 nodes that you've created. So we need like a little bit of extra code, like a very, very small amount extra, just to kind of make it scalable. So if we come to locations here, we're going to drag one more thing off, which is, what's the word? It's not total. Length of list. Yeah. So that is going to give us the wrong number. That's going to give us 5 instead of, which is technically correct, but we want for this maximum, we want it to be 4. So what we want to do is integer minus integer. So we're going to reduce that number by 1. So it'll reference the locations. It'll get us the length, which will be 5. It'll deduct 1 from it. So whatever the length is, it'll deduct 1 from it and then set that as the highest maximum number of positions it can move between. So no matter what I set this to, so let's say if I took out one of these locations, it wouldn't throw a reference error. You know, it would adjust. Yeah, which sometimes in games you might want to have situations where, let's say you've got multiple of these nodes, but objectives change within the level. You might want to have these, these node positions update in time. So being able to kind of adjust that without breaking the code is pretty useful. So yeah, so that's all great now. Let's actually get back into the space. Ooh, didn't like that. So what you'll notice about this is the AI will chase us. See if I can get it. I need to run away. I can't find a way to hide. And it should have created more hidey spots in this level. Yeah, okay, great. So you'll notice this is not great. So the AI I managed to outwit the AI and escape them, and now they're just stuck there because they have kind of left their routine of running around, but they've also stopped seeing me. So there's one more piece of code we need to add to this to really make our AI have some teeth, which is we need to have it that if it loses track of us, that it will continue to patrol. So if it finds us, it will continue to patrol, and if it doesn't find us, it will continue to patrol as well. You can adjust this, in your own project. So, if you wanted for your own gameplay sequences, where let's say if you find the player, you actually probably want to like attack or sound the alarm or something like that. But for the purposes of this, once I've successfully escaped, which if I can do, it will. Come on. I need to be able to not see that I can see you message popping up. I mean, the easiest way for me to do it is just to be a coward and do that. So you can see the AI just goes back to its routines. Yeah, so you can, even with this like very, very basic AI setup, you can get something that's reasonably compelling. And as I said, the interesting part is how you implement these systems. So, having maybe an AI's field of view be limited, having not a completely random system for these. Sorry, where am I looking? For these like locations, it's choosing maybe if you have like let's say a whole warehouse, or even just like the full extent of this space here for your project. Let's say that you've got like a warehouse for your space. and you get spotted in this sector here, maybe you'd have it that the AI only patrols in these sections here for a period of time to try and kind of hunt you down, rather than going, running to like the furthest possible point on the map. Yeah, there's so much kind of elegance you can design into these systems to make them more compelling. As I said, we'll just do that last comment of our code. So this is going to be a long one. You might want to, personally, what you might want to do as part of this is break this up into multiple bits. So I might just break this into this here. So so on event begin, find all nav marker references, assemble into a list of locations. And then for the next bit, knowing how to kind of group your code is a pretty good idea. So I think I'll group these. So get length of location list, deduct 1 to give randomized range of location targets. And finally, custom event that chooses a random marker to target, something like that. Yeah, so now you've got these. Get rid of that. Yeah, you've got this logic that gives you basic AI input, and then from here you can experiment further, and do whatever you fancy. So that's basically everything I wanted to cover. I'd encourage you again to expand beyond this, in your own kind of gameplay sequences. Look into how to get AI to kind of move beyond doors. Look into maybe you look into navlink proxies to kind of give more fluid vertical movement between different spaces. There's a lot you can kind of explore with this stuff. You don't even need to get too complex. There's the only other thing I'll quickly mention, which is pretty neat as well, is that there is a where is it? Nav modifier volume. So what this does is this basically, as you can see, designates a space that the AI can't move through. So it kind of eliminates a section of the nav mesh. And not only can you designate it as a space that's a no-go zone, you can also kind of designate like a threshold for how risky the space is for the AI to move through. I can't specifically remember how to do it because it's been a while since I've dabbled with this particular part. But what's nice with this is that you can basically set the priority for the AI. So like if it is a completely impenetrable route otherwise, so let's say you're building your kind of containment, alien containment game or something like that, and you close like a blast door that kind of keeps them out, but you've still got a corridor to the side that is like blown up on fire. You can basically say that if the AI has no other means of getting through, you can take that painful and risky route to reach the player. And then you can get into a lot more nuanced stuff. So you can say like, hey, how much health have I got? If I've got more than, let's say, 80 health, I can take that route. Otherwise, I'll wait. Because obviously if they take that route and they've got less than that amount of health, maybe they'll die. So, you can then start messing with like custom variables. So like, and maybe there is a point where like let's say the player has collected all the card keys they need to escape the spaceship, maybe they'll be willing to cross that boundary, and then you can get into even more exciting stuff. So maybe make it that if they do walk through that space and catch fire, maybe they run a little bit quicker. So like this is all like the nuances of like what you can explore with these tools. Like with very, very basic setups, you can achieve some really kind of atmospheric and exciting stuff. Cool. So I'll leave it there. If you have any questions, just let me know. And thanks for listening.